Hi, I'm Forrester King, and this is my project for COSC 428, which is a computer vision paper at the University of Canterbury. Now it's taught by Professor Richard Green, and I did my project based off of a previous one by Nicholas Renotte for drowsiness detection. Now I'm going to link his channel down below just so that you can follow along the tutorial that he has as well. Now I altered mine so that it's for student fatigue over time, especially during screen time. So I'm just going to run it and explain through how it all works, and we'll go from there. So at the bottom here you can see this is my setup and the model that I'm using. And yeah, hi. So you can see here that I'm 94% focused, I would say, and that's off of a bunch of images that I trained it on. So I trained it on images for me being focused, having my correct posture, looking straight ahead at the screen, and just generally being focused. But I also trained it on a whole nother class of images for me being, if I start to get tired, fatigued. So it gets a better score the more I'm like, my head's down, the closer I am to the screen. And it can detect a whole bunch of range. So it can detect me while I'm like this as well, completely head down. Yeah, that's pretty cool. So this all works using three things. I used PyTorch 2 for the deep neural network for optimized tensor library learning. So I think that's the correct way to say it, but pretty much I can train it on a whole bunch of images, and to do that I use a thing called, if I run it here, it's called open labeling, and I did a modified version of it. And pretty much I can put a boundary box on a whole bunch of images to say that, hey, I'm fatigued, or I'm yawning, or I'm focused. And so I just go through all these images. Oh, he's quite close. And yeah, you can pretty much build a model off of that. So I have 135 of them. It also detects yawning. So it might not show up because the dominant one is focused or fatigued, but if I yawn, it might come up, maybe not, doesn't matter. It's still getting recognized in my tracking software that I'm using. And so I built this model, right, using this library, and I'm accelerating it to use real-time tracking with my CUDA cores on my computer. But then to actually do the tracking and object detection, I use a thing called YOLO v5. So that is the you only look once algorithm. And it's for speed and accuracy. So it's, sometimes it's been trained to 200 epochs, but it sometimes picks up random things here and there, or gets false positives. Because ideally I'd like to have over 1,500, say, images trained on it, but I've only got 135. But yeah, I use that program for doing the actual object detection in real time. And additionally, the PyTorch 2, I can train it up. So I got those 135 images. I have all these ones here too. So these are for slight changes in depth, hue, translations, multiple images on the same thing at once. And that's just to help it create a larger data set. And yeah, so that's pretty much how it all works together, if that makes sense. Now, if I quit out of here, we can actually see that, I gotta quit the program first. So there we go. Here's the real-time tracking of me being focused. And as you can see, yeah, I'm recording a video, so it's pretty much focused the whole time. So my score is just up the wazoo. But yeah, that's how it works. I'd like to develop it further so that it detects yawning better and having a larger data set so that I can get better recognition with more people. Because at the moment it just works on me, but it doesn't work on anyone else. Well, it does, but it doesn't work as well. It gets about like a 60% score for accuracy, where on me it's like up to 95. So yeah, thank you for watching, and bye.